As discussed, there are approximate values that we can use to determine the area under each portion of the curve. Before we get to them, let's talk about how the curve is broken down. We already discussed the mean and standard deviation, how they affect the graph. But before we go on to anything else, let's talk about the actual breakdown. So unfortunately, this is going to be very hard to draw on, but I'll do my best. So the mean's in the center. I'm going to say right here, this distance here is 1 standard deviation. Here's the thing. Now, before I mess it up with symbols, let's talk numbers. Let's suppose the center was 5, and I told you the standard deviation was 1. Well, what number would go right here? Hopefully you said 6, because that is 1 unit to the right of 5. And then next would be 7, and then would be 8. We normally go out 3 in each direction. We'll see why later on. And then, same deal. If this was 1, what number goes here? Hopefully you said 4. And then again, we go 3 in each direction. Okay. So notice to get the 6, we did 5, the mean, plus 1, the standard deviation. To get the 7, you did 5, the mean, plus 2 times the standard deviation. And to get the 8, 5, the mean, plus 3 times the standard deviation. I'll just put another set of parentheses. And same thing over here. To get the 4, we did 5, the mean, minus the standard deviation. 5, the mean, minus 2 times the standard deviation. 5, the mean, minus 3 times the standard deviation. So we're just adding and subtracting the standard deviation over and over again. So going back to the normal curve, if this is the mean and this is 1 standard deviation to the right, then this is mu plus 1 sigma. And then we have mu plus 2 sigma. And then we have mu plus 3 sigma. Then we can go the other direction. Mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. There we go. Okay. So that's what the tick marks are going to look like. Again, the center one is the mean where the graph is centered, and then we go out 3 from each side. Notice there is going to be a little overhang after the third one. That's totally fine. You'll see how that plays out when we get to the next slide here. Before we continue, just some terminology. No, what did I do? What did I do? Okay, I'm better now. Okay. Let's talk about the number 6. The number 6 is 1 step to the right of the mean. And the 1 is important because that was the standard deviation. So we would say that 6 is 1 standard deviation above the mean. That's the formal way. 1 standard deviation above the mean. And how about 7? 7 is 2 spots above the mean. So we would say 7 is 2 standard deviations above the mean. And how about the 2? 2 is 3 standard deviations below the mean. So they're going to talk about in the book and in the videos, you'll see that they talk about certain directions from the mean, above and below. Now, if they don't give a direction, like if they just say 2 standard deviations from the mean, well, that means if you go out 2 in both directions. So 2 to the left and 2 to the right. So that would mean from 3 to 7 is the range from 3 to 7 is 2 standard deviations from the mean. All right. So now let's talk about this rule that approximates the area under each curve. Oh, before I do that, 2 things. Two things to remember. One is the area under the curve is assumed to represent 100% of the population. So for any question you have, everyone is somewhere under this curve. So if you had a height of a student, then they must be somewhere along that range. There must be a height that exists that match their height. Since we have symmetry, then, let me change colors real quick. Since we have symmetry at the mean, and if the entire thing adds up to 100, that means 50% of the population are within each part. So if, for instance, the average age of a kid's birthday party is 12 years old, making that number up, that means half the children there are under 12 and half the children there are over 12. So if they asked you the question, what's the probability that a child is under 12 years old, you'd say 50%, because the median age is 50%, or the mean age, is 50%. Okay, now we're going to see how the sections break up. And remember that because we don't have a straight line going across, each section does not have the same value. To break it up, we need the 95-99.7 rule. I'm getting a little parched, so you can just read that. I have nothing to drink. Do I? No, I didn't bring anything. All right, 68% of the measurement is within 1 standard deviation of the mean, 95 within 2, and 99.7 within 3. Keep those numbers in mind. Let's see how this breaks down our normal distribution curve. All right, so we're going to fill in the normal bell curve. I would suggest I'll keep purple. I would suggest that you draw this as well as we go along. All right, I'm going to draw possibly the worst line of my life. No, stop it. No. Oh, can I draw a line? No, I can't draw a line. Oh. All right. It's so hard to draw on a tablet. Oh, that was terrible. So here's the mean, and I'll just put in the other things. Oh, I forgot my 3. 3 sigma. Then I'll go the other way. Oh, I botched that severely. I severely botched this. Don't tell anyone, please. Okay. So these are all going to have... It is so hard to draw on this. Doing it. Okay. Okay. Put black. Okay. So remember, the entire curve underneath the curve represents 100%. Half the mean and up is 50%. Half the mean and down is 50% as well. So now we're going to do each section, and we have 1, 2, 3, 4, 8 sections total. Okay. And then we're going to see a numerical example of what the heck's going on here. Don't worry. It will make sense soon, I promise. Okay. As discussed, 68% fall between 1 standard deviation of the mean. So this section right here, these 2 sections, I should say, this one and this one, need to add up to 68%. Due to symmetry, we can cut the 68 in half, and how much are each section worth? Hopefully you said 34. So these are 34% each. Good. I'm going to clean up that 34 because it looks like a 39. I didn't mean to do that. Boop. Okay. All right. Next up, you are told that 2 standard deviations of the mean, meaning from here to here, adds up to 95%. Well, the 68 is within the 95. So if you took 68 from 95, that gives you 27. 27 divided by 2 makes 13.5. So these 2 sections out here represent 13.5%. So all 4 of those sections now, if you can check, they should add up to 95%. Okay. And then we are told that 3 standard deviations from the mean add up to 99.8%. So from here all the way to here is 99.8%. Oh, 99.7. 99.7. I'm so sorry. 99.7%. Notice those 6 sections include the 95%. So if we subtract the 95 from the 99.7, that makes, what is that, 4.7? And then 4.7 divided by 2 is 2.35%. Okay. But what we started with was that all the sections need to add up to 100%. We have 99.7% accounted for, which means we're missing 0.3%. So the outer two most sections, this one and this one, need to add up to 0.3%, which means that individually they are 0.15%. So if your data values are a standard deviation away from the mean, a whole standard deviation away, 1, 2, 3, -1, -2, -3, you can use the 68, 95, 99.7 rule. That might not make any sense until we get into 310, which is fine. This rule is for approximation purposes only. In fact, I think that's the next slide. It's a warning. So if you need to pause the video before I move on to the next slide, do it. Okay, I'm assuming that you paused the video. So again, this is approximation purposes only. The actual values aren't really 68. It's really like 67.6% and not really 95. It's really 94.3%, something like that. They just use this to make your life a little bit easier for those scenarios where it's a whole number away. But if you wanted something more accurate, you would need a chart, which is what we're going to do in 3.10, or you need calculus. That's why it's in the scary font. Okay, so watch the video called the 68, 95, 99.7 rule, and it shows you how to use those numbers to find probabilities that I think a person is a certain age at a construct.